Hello everyone, this is Anas Sheikh, and today I would like to be presenting to you all a seminar on multi-criteria reverse engineering of food systems, and we will talk a bit about this concept. So, first of all, on the very title slide, we have a very good example of how this concept of reverse engineering works. So basically, we have an impossible burger, as some of you must have heard about the impossible burger. It's actually a burger which is made up of completely uh, plant source based ingredients. However, it tastes much like a non-vegetarian burger. As we all know that these days the concept of sustainability is coming in uh, more so because of the global impact of climate change, and we are moving towards more sustainable solutions in engineering problems. So this is where people are trying to look for alternative means for developing solutions that are sustainable and do less harm to the environment. So this is the Impossible Burger, and the company when it had to target it's a burger which was made up of completely plant-based ingredients and having a similar sensory profile as that of a non-vegetarian burger. So they had a target clear in their mind, and later on, which they basically uh, came down the path. So they did not begin with a bottom-up approach, like they did not start with the ingredients and did trial and error methods, but rather they went from top to bottom, and that is how they did reverse engineering rather than engineering. So let us see some more examples and this very concept of reverse engineering and what exactly is multi-criteria reverse engineering. So the contents of this presentation are from a review paper which was published by Thomopoulos et al. And in Food Engineering Reviews journal, and we will be exploring what these authors have to say in their paper. So coming on to the need for development of sustainable processes and products. So sustainability, as we all know, that is a integration of different criteria, including technical, economic, consumer demands, and environmental criteria. And the United Nations has set up sustainable development goals which are to be achieved by the year 2050. How do we use these concepts, or how do we implement this concept in our area of research, which is food process engineering? So there is always a balance which needs to be struck in the food sector. That is when you give more priority to nutrition, sensory, health and hygiene, and waste-free concepts for or solutions for the food industry. Sometimes it tends to be compromised with the product cost, with the operations that can be possible and that are scalable, and also the safety aspect of food products. So, for example, in our houses, we make thermally processed foods. Like thermal processing is quite a major processing technique which we use in our day-to-day lives for cooking. But in thermal processing, there is a loss of nutrients such as vitamins. However, although this loss of nutrients is there, one thing that thermal processing secures is the safety of food products, because the microorganisms are killed in that process. So, if we give minimum thermal processing, then although we will save on the vitamins, etc., we will be compromising with safety, and the food may get spoiled early. So this is where a balance needs to be struck in the food industry, and therefore defining sustainability is rather quite complex and involves these various criteria such as technical, economic, consumer demands, and environmental criteria. So, as we all know that what exactly is the traditional approach that we all follow to make food products? That is, by and large, the cook and look approach. So, in the cook and look approach, what we do is we actually make food products out of some ingredients, and then we cook it, and then we look at it. So we look for if the viscosity is consistent, if the texture has come properly, and then if it's not proper, then we again have to perhaps cook it. Or sometimes if it's not done properly, then we actually have to redo the entire process. So sometimes this can be really annoying and frustrating, and it may lead to somewhat randomized attempts and also increased consumption of time, energy, and effort. So, in order to reduce this and these uh, difficulties which are there in the cook and look approach, we make use of the knowledge that we have accumulated about how uh, the various properties in during food processing affects the structure and functional properties of foods. So in another webinar, I'll be explaining this concept of soft condensed matter physics of food systems, wherein we use physics-based models to know how exactly the various interactions among the different ingredients of foods affects the texture. So, for example, the emulsion structure, how it affects the mouthfeel of ice creams. Similarly, how the emulsion structure, or rather the interplay between ingredients of chocolates, for example, the lipids, sugar molecules, water affects the mouthfeel of chocolates, and also how the gluten network affects the texture of bread. So, having accumulated this knowledge about the structure and functional properties and how these can be tailored by appropriate use of unit operations and appropriate use of food equipment, we can use this knowledge to have a multi-criteria reverse engineering approach, wherein we know that by applying certain operations and certain equipment, we get a particular structure and function of food products. So by using those models, we can actually predict how our final food product will look like, and this will hopefully reduce the efforts that are involved in the initial prototyping and initial trials, which are conducted for uh, food product development. So now we come to the pivotal steps which are present in this very concept of multi-criteria reverse engineering. So as we can see from the name, that multi-criteria reverse engineering has two different rather phrases from which we can guess which will be the two logical steps in it. First step is reverse engineering, and the second step is multi-criteria. So let's come to the first step, which is reverse engineering. So in this concept of reverse engineering, when seen from a food industry perspective, it can be seen in this way. So in the food industry, traditionally what the food industries did was that they learned from their experiences. So they would design a particular product, and they would launch it in the market, get the consumer feedback, and learn from their experience of that consumer feedback, and then they would improve their product. Now, the time that this particular approach of forward engineering in a way which was traditionally followed by the food industry uh, reduced innovation in a way because of the time that it took to get consumer feedback and then improve the product according to it. So this particular approach, in the light of reverse engineering, changes to a dynamic one, which means that companies now keep a track of the consumer trends. Uh, and they look out for what exactly are the consumers' demands. So, for example, in the recent times, because of the COVID-19 pandemic, people have become more and more health conscious, and rather than trying to eat foods that are simply just tasty, consumers are also looking for foods that will also deliver health benefits to them. So, looking at these trends, companies are now making products in that fashion, which products with low GI, that is glycemic index, products that are rich in certain bioactives, etc. So this is where the food industry is slowly adapting to a reverse engineering approach, and which is the first step in multi-criteria reverse engineering. So, and yes, thereby the like making food, what seemed to us like a culinary art for a very long time, has now been transformed into food science, and therefore we need tools and decision-making systems so that we can integrate these uh, uh, knowledge about the food systems that we have accumulated so that we can use it for better design and optimized food products. So coming on to the next step of our multi-criteria reverse engineering. So having seen the first step as reverse engineering, the next is to incorporate multiple criteria. Now, often when I talk about, let's say, for example, ice cream. So, if I ask a consumer that what exactly do you look for ice cream? And in general, for when we ask people about food, sometimes they may simply say, okay, I need a good taste. But yes, these days the consumers are also wanting foods which give several other benefits, like they should be giving health benefits rather than just simply taste. They should also be economically feasible. That's also uh, criteria which consumers look out for. What's the cost of the food product? Another is, since more and more people are now becoming aware of uh, the the impact of climate change, also the recent heat wave that we had in India. So, and there are several lots of other global climate change events which are happening, and consumers are wanting to have reduced global temperatures and to combat global warming. So, they also want companies to adopt more environment-friendly techniques, such as not using plastic products. So these are the various criteria which are to be considered by companies while designing their products and processes. So that is done by setting a goal. So, like I said, the entire concept of multi-criteria reverse engineering is based on setting targets and then accomplishing it coming to backwards. So, for example, if a company targets low pesticide contamination risk, which is a health criteria, then they will track it that where exactly the pesticide contaminations are coming in. So, they will make their processes in such a way that it removes a lot of the pesticides, and that is how that process can be designed. Uh, so this is all about the concept of multi-criteria reverse engineering, rather an introduction to the topic, and I hope you all liked it, this concept, and I hope that it helps uh, to it helps us to apply this concept in our research, and also in different aspects of our life wherein we can use already available models to analyze what outcomes we may have, and then take the steps accordingly so as to be able to save time, energy, and efforts, and also uh, conserve the environment around us. So thank you so very much for listening, and have a nice time.